Before I start, I'm just going to let you all know this is at least my third time on this video. I'm pretty sure it's my fourth because I'm having technical difficulties, so I hope you appreciate my pain. This is lesson 3.2, and the lesson is called Graphing Linear Equations. You're going to learn many different ways to graph linear equations throughout this chapter. The first way you're going to learn how to do it is with a table. And before we actually do that portion, I'm going to have you check to see if some coordinates lie on the graph of the line. And to do that, it's simply a matter of substituting in the x coordinate and the y coordinate into the equation to see if a true statement is formed. So let's go ahead. We have 2x plus y equals 10. I want to know, does the point 4, 3 lie on this line? So I have 2 times 4 plus 3, and I need to know, does that equal 10? So 8 plus 3 actually equals 11. So if I were to graph this line, the point 4, 3 would not fall on the line. Let's try it with this next one. I have 2 times negative 4 plus 18. Does that equal 10? That gives me negative 8 plus 18, which does equal 10. So 10 equals 10. So this point would lie on the line if I were to graph it. Let's try one more of these together. I have the equation x minus 3y equals 12, so 9 minus 3 times 1, does that equal 12? In fact, 9 minus 3 equals 6, so this point would not lie on the line. Here I have 6 minus 3 times negative 2, does that equal 12? Negative 3 times negative 2 is positive 6, and 6 plus 6 does equal 12. So this point would lie on the line, and this one wouldn't. I want you to come in tomorrow with number 3 completed, and we can check it over to see if you're correct. 7, 8, and 9, you're asked to put the equation in function form. They're just simply saying solve it for the y. We did this in last chapter, so it shouldn't take us very long to do this. It's just a little refresher. So I want to eliminate the x term. This is a negative 4x, so I will add it to both sides. Remember, to eliminate an entire term, you must add it or subtract it. So we get 2y. I like to write this with the x term first. It's a positive 4x, so I just write 4x out in front. It's a positive 16, so plus 16. Then you divide every term by the coefficient. So y would equal 2x plus 8. Let's try this next one. Again, I want to eliminate the x term, so here I'll subtract the 10x from both sides. I bring down negative 5y. This is a negative 10x, so I'll just put that out in the front. That's a positive 25, so I write plus 25. Divide by the coefficient of negative 5 everywhere. And y equals positive 2x minus 5. Again, I want you to come in tomorrow with number 9 completed, and we'll check it over. Next, we're going to actually graph the equations. And the first thing I want you to do is solve for the y variable. It's just easier to set up our table if we have solved this for y, and eventually you're going to have to do it to put it in a certain form anyways. So number 10, we have y plus x equals 14, so we'll simply subtract the x from both sides. So y equals negative x plus 14. Recall that negative x means take the opposite of x. If it helps you, you can always write down negative 1x. I'm going to look at my x-axis, the way that they've set it up here, to go ahead and try to choose my domain. Remember, your domain or your inputs are your x's. So I'm going to do a negative, so I'll do negative 4. I like to do the origin because it's pretty easy. And then I'll do the positive 4. So you need to do at least 3 points. And I know that some of you at least know that you only need technically 2 points for a line, but 3 points gives us just a better set of points to graph it through. Okay, so we're going to take the opposite of negative 4, which is 4, plus 14 is 18. The opposite of 0 is 0, plus 14 is 14. And the opposite of 4 is negative 4, plus 14 is 10. And now I just plot my points. So I have negative 4, 18. So this is 14, or sorry, 16 and 20, so here we go. 0 is 14. And 4 is 10. Now I chose this as my domain, but my domain really could have been any numbers, and because they could be any numbers, we're going to go ahead and connect this with a line that has an arrow at both ends. This just shows me that my line will go on to infinity in both the positive and the negative direction. It is important that you put the arrows at both ends because the lesson we're going to do tomorrow, or the video notes for tomorrow, we're not always going to graph a line, we'll graph a ray or a segment. All right, let's look at number 11. Again, solving this for y, I'm just going to add the 5x to both sides. So I get y equals 5x plus 2. And I'll make my table here. Now I will tell you this is one that I did before, and I know they've set it up to go in twos, but I'm going to go ahead and just set it up to go in, I'm going to try -1, 0, and 1. And the reason I'm doing that is because when I did it before, it went off the graph, which is okay. You could always extend your x and y axis, but since I already know that, I'm not going to. So 5 times -1 is -5 plus 2 is -3. 5 times 0 is 0 plus 2 is 2. 5 times 1 is 5 plus 2 is 7. So I have -1, -3. 0 is 2. And at 1, it's 7. And this, just trust me, fits on so much better than my last one. And again, we have the arrows at both ends. I want you to come in tomorrow with number 12 completed. If you have to look back here to see what to do if you have a coefficient with the y, then go ahead. And it will work if you use -2, 0, and 2 for your domain values. So I want you to do number 12. Number 13 looks a little different. We have x equals -6. So if I made a table for this, my answer for x the whole time is -6, -6, -6. My y, I can make a -2 and a 0 and a 2. It doesn't really matter. So at -6, I get a -2. At -6, I get 0. At -6, I get +2. This is a vertical line. I'm not going to require you to make a table for a vertical line or a horizontal line. I do want you to write down, though, that if x equals, we're going to call it a, it's just a number, then it's a vertical line. Now we have y equals 4. Again, we could make a table. I could do x as -2, 0, and 2, but y is always 4 according to my rule. So at -2, I get 4. At 0, I get 4. At +2, I get 4. So this is a horizontal line. And again, I won't require you to make a table as long as you know that when when y equals a number we'll call b, it's a horizontal line. Okay, so this wraps up the notes. This is what's going to be covered in tomorrow's lesson. You're going to have to check to see if points lie in a line. You're going to have to change equations into function form, so solve it for y, and then you're going to have to do some graphs. Here's the lesson if you'd like to get started early. It's 3.2 Part 1, page 157, problems 1 to 10, 16 to 25, and you will need a piece of graph paper to complete them.